to the 0 power is going to equal to 1. So 789 raised to the big it is, if it's raised to the 0 power, is going to equal to 1. Why that is, that's for another time. To the first power. Any number raised to the first power. Another example of this would be 23 raised to the first power. It's going to be 23. So any number raised to the 2 raised to the third power can be rewritten as so. 2 times 2 times 2. If you solve this 2 times 2 times 2, you could rewrite it to be 2 raised to the third power. These are one and the same. They're the same. So now that we know that that 2 raised to the third power times 6, or 6 times 6 can be rewritten to look like 6 squared. They are one and the same. So now that we've broken down all of these numbers, let's rewrite them like they are on this side of the equal sign. We multiply all these together. So 2 times 2 times 2 is going to give us 8. 5 times 6 is going to give us 30. And then 6 times 1 is going to give us 6. From here, let's do 8 times 30, which is going to give us... From here, what we're going to do is 8 times 30, which is going to give us 0 and 24. So 240. 6 times 0 is 0. 6 times 4 is 24. Put the 2 up here. 2 times 12, it's 2 times... This question is asking, compute the prime factorization of 432. Before we start this problem, let's understand what a prime factorization is. A prime factorization is when you take a number and you break it down to its bare bones, to where it can't be divided any further. When you do your prime factorization, the numbers that are going to come out are prime numbers. Prime numbers are numbers that can't be divided other than by 1 and the number itself. So for example, 1 can only be divided by 1 and 1. 2 can only be divided by 1 and 2. So let's break this 432 down to its prime factors, to its bare bones, to its point where it can't be broken down any further. I'm going to start by building a tree. Now generally what I do is that I divide it by 2 until I can't divide it by 2 any further. So I'm going to put 2 on one side, and this is going to be 216 on the other side, because 2 times 216 give me 432. 2 can't be broken down any further, but 216 can. So we're going to break down 216 into 2 and 108. Then we're going to break down 108, which is going to be 2 and 54. And let's break down 54, which is going to be 2 and 27. Now, can 27 be divided by 2? No, but it can be divided by 3. 3 and 9. Can 3 be broken down any further? No, it can't. But 9 can. 9 can be broken down into 3 and 3. So there it is. We have all these 2's here that can't be broken down any further, and we have all these 3's here that can't be broken down any further. So, taking the 2's, I'm going to rewrite them as being multiplied together, and I'm going to take the 3's and multiply these together. So another way of looking at 432 is 2 times 2 times 2 times 2 times 3 times 3 times 3. Now this is a long way of writing this out, so I'm going to condense it further by writing it in exponents. So another way of looking at 2 times 2 times 2 times 2 times 3 times 3 times 3 is 2 to the 4th power, because there are 4 2's, and 3 to the 3rd power, because there are 3 3's. So 2 to the 4th times 3 to the 3rd equals to 432, and these would be the prime factorization of 432.